cold open, warm open, I don't know. Rust 164, welcome everyone. Another patch review. Rust 164 dropped yesterday.
24 hours ago. Exciting.
So a bunch of new features came out. Got them right here. So Rust comes out every 6 weeks. Patch dropped yesterday. You can update now.
Rest update stable.
Shit. It is true. It is true. It is what you do.
We're like the marketing team. It's awful. Awful. Absolutely awful.
It's fine. It's fine. Look. There's text on screen, and we can read it, and we can move on. Pretend that didn't happen.
Yeah.
So Rust 164. First off, feature I worked on together with my colleague Eric. We now have IntoFuture in the standard lib. So
What does that mean?
what does that mean? Well, let me tell you. I wrote this text actually. So Rust 164 stabilizes IntoFuture, which is this trait over here. You can find under std_future, IntoFuture, right there. It's I'm just gonna read it out. So IntoFuture is a trait similar to IntoIterator, but rather than being designed for like for in loops. So when you have a for in loop, it calls IntoIterator on whatever you is on the right hand side of the in. IntoFuture converts a type into a future. So instead of like being able to just await futures, you can await anything that can be converted into a future. So you can implement IntoFuture on it. So
What are these things, before you give us an example, what would you use something like this for? Is that what the example is like?
That's my examples for that.
Cool. Sure, show us the example then.
So, well, it like the example is essentially, so here's the HTTP client that I helped author. So here you have like a thing called serve get, right? And then you await it. But instead of like saying serve get and then like straight awaiting it, you can also say serve, for example, here's a different method, like post or whatever. And you can give it a body. And you can be like, here's the data to send, and then we await it, right? Or you can give it like headers, and then you await it. This is an example of an async builder, or like a general like builder pattern. But instead of saying .build.await or .send.await, you can just call await and it gets converted into a future for you.
Right.
So it shrinks down the usage a little bit.
And so IntoFuture for this particular example would help you convert this JSON data into future, I guess.
Yeah.
To reiterate the use case.
So what we used to do here in the past is we just implemented the future trait on the builder, and the conversion into, like, it wasn't actually a future,
right?
But the conversion into a future would just happen under the hood,
right?
Within the same type. It's very annoying because you gotta like do a bunch of stuff, but now it can be like done in a much more easy way by differentiating between conversion into a future and the actual future.
Nice.
Now the example here is sort of like a minimized construct for the Azure SDK at Microsoft.
Okay.
The Rust Azure SDK. We've adopted the IntoFuture pattern under the, we're going to stabilize it later on. And this is like a simplified example of what we're doing there. It's a bit, I don't want to say contrived, but a bit more involved than like a hello world type of example would be. But it's a more realistic one because it shows some of the difficulties that emerge from us not having all the language features yet. I don't really spell it out, but here, this is the workaround for not having impl trait, type alias impl traits. So here instead, you manually create an alias by pinboxing it.
Okay.
Right. But in the future, this will just work. You can just say impl future here, and then this will just work, and you don't need to worry about most of these things because this can just be, what is that? Yeah. It will simplify. It'll be simpler. That's all you need to know.
Do you want to go through the example for real?
Yeah, for sure.
I also kind of like that you're doing like a more realistic example, because with things like this, I usually find the hello world a bit frustrating to read when I'm trying to just figure out how it actually works in real life. So
Yeah. So if you want like a more hello worldy type of example, like this is kind of it, right? Here in the docs, let me up the font size slightly. Here the IntoFuture docs, I was like, cool, you can multiply two numbers. I also wrote these docs. Like you can multiply two numbers. Isn't that fun, right? But it's very artificial. Like this feels more real of how we are actually using it, how I've been using it. And there's some more stuff to it I'll get into in a sec, but let's go through the example first. So assuming a type error, some struct response, some struct request, here we create all the methods on it, where this thing just stores some Boolean, right? Like a flag, like, hey, are we in debug mode or aren't we? So it can create a new thing, and there's a final method to send the request. And the only variable there is it in debug mode or isn't it? Now, the way you would do this is like, you create a new request, then you set the debug switch. By default, it would be false, but if you want to turn it on, you set debug. And then there's send, and then there's await. So constructing the future and executing the future are two separate steps. But using IntoFuture, we can combine constructing the future, obtaining the future, and running the future into a single step, because await just does that. So it removes sort of like an intermediate, like just a method call.
So then IntoFuture is sort of, well, because it is a trait and trait is implemented onto the storage request, correct? It's a bit, it becomes, the IntoFuture conversion becomes a bit more implicit in this particular use case. Implicit being perhaps a wrong word to use here, or what do you think?
So both yes and no.
Okay.
How do I explain this? Implicit is a word that I've seen people use, and there's a real question of like, what does send say here? Like, what is the value of having send right here? Maybe some people say, well, explaining that this is a send action is hyper important. Like, we should really keep it. And that's a fair argument, right? But oftentimes, at least in this case, I don't find that send, like a verb send, carries its value. Like, if you are doing a lot of like requests, then, it's a lot of like repetition of just send right there. And to me, the await signifies that IO is happening already, like await question mark says, hi, I'm doing IO, like async IO. So the value of the send call is actually, for me, more represented by the await. Opinions may differ. That's fair, but there are other instances where like this may not be .send, it may be .build or something else, and this collapses it in. Anyway, that's the decision that we've made for the Azure SDK, and this is a small representation of that.
Okay.
Does that make sense?
For me, yes.
Okay.
Our viewers will tell you in comments.
Please do not tell me no. Yeah. Anyway, here it's the implementation of IntoFuture for storage request. Here we create a type alias. How does this work again? Oh yeah, we have send right there, but we also have the conversion into the future right here. And here we can create an anonymous future, which means you can implement everything using just async functions, right? Here we just call self.send, and send is an async fn. And there's the only annoying part is having to write this, but you don't have to manually write box pin state, like box pin or pin state machines or any of the poll thingies. This is how you implement the trait using pure async functions.
Poll thingies is a technical term.
Yeah.
Very nice.
Yeah, when you implement futures by hand, there's a lot of like work involved to manually ensure that every point of the state machine is correct and all that stuff. It's very annoying. Async functions generate that stuff for you. So in this case, you just need to add this, and an existing async function will just continue to work. Because we use this async function signature as the return type for this future. Bit contrived, bit annoying. It will get better once we have type alias infiltrate, but we don't yet. But we may by the end of the year, hopefully.
Hopefully.
Yeah. Anyway, yeah, here I spell it out. I said like, hey, once we have type alias infiltrate, this will become easier, and we can remove the boxing, and like life will be better, etc. Anyway.
Cool.
Now for what this might actually enable.
Oh yeah, tell us about that.
Yeah. So this is like in user like in library code for the Azure SDK. Like we want this. It will benefit us in Surf as well because we can simplify a bunch of stuff. There will likely be other patterns like other libraries which enjoy using IntoFuture, just like people enjoy using IntoIterator or the into conversion for errors is very similar. But there are actual like patterns that this will enable in the standard lib potentially. Like it will enable them. Whether we adopt them is a second question. No decisions made yet. I should highlight that. But going down here, what if you could have like here's like 3 futures, right? 3 separate futures. You stick them in a tuple, and if you then await the tuple, it resolves concurrently to the output, right? So instead of saying this tuple dot join dot await, we would be able to just directly await the tuple.
Nice.
Because the tuple would implement IntoFuture.
Nice.
And says, I know how to return a future that is the join of all of these things, and then await it. So it becomes a single step.
Just becomes very tight and very ergonomic. I really like that. I think it just makes the language look good in general.
Yeah, I think so too. It would apply for, say, vec as well, and like arrays as well. The only thing is like it would always be join semantics. Read the post for why that's actually a good thing, and other like concurrency semantics make less sense. But yeah, this mirrors a feature that Swift has here, where they used to only have like groups. So here you have a group, and you would spawn new tasks on the group. They changed it to async let. Now you can also do this, and here you can see the concurrent await, right? Like these two async future. I'm not sure if they call them futures. They execute them concurrently, and we will be able to mirror the feature. Whether we will, it's not been decided, but I would be in favor of that because I really enjoy this. I think mirroring this pattern is a good thing. Anyway, IntoFuture enables us to go down that route, so pretty excited for that.
Nice.
All right, that was a lot of words.
I think that's a really useful feature and just kind of requires, I think, a lot of explanation. So it was good.
Yeah.
I enjoyed hearing about it for the upteenth time.
Yeah, my God. Guess I've been talking about it a bunch over the years now. Yes.
Just the benefits of living with YOSH.
If you're a cat, I'd recommend it. Otherwise, oof. All right, shall we move on?
Yeah, let's move on. So the next thing that got merged in is the C-compatible FFI types in core and alloc. When calling or being called by C ABIs, Rust code can use type aliases like cuint or culong to match the corresponding types from C on any target without requiring target-specific code or conditionals. Previously, these type aliases were only available in STID, so code written for embedded targets and other scenarios that could only use core or alloc could not use these types. So Rust 164 provides all of the C star type aliases in core FFI as well as core FFI C star for working with C strings, and Rust 164 also provides alloc FFI C string for working with own C strings using only the alloc trait rather than the full stud library. This feels like really cool for embedded Rust stuff. I feel like everybody who does embedded is just going to be like really happy about this.
Yes.
I feel, yeah, that just seems. I read this. I didn't pre-read the patch notes, but I'm reading this, and I'm happy for embedded Rust developers. Imagine not being able to have like access to uint FFI in embedded Rust. That's.
I mean, I believe what they just did is they made their own, right?
Yeah, but I mean that's a lot of work. Speaking as somebody who tried implementing Float 128 in Rust, that was a lot of work and a lot of spec reading. So yeah. Cool.
Easy win. This seems like an easy win. Happy
happy.
All right, next up, Rust Analyzer is now available via rustup. So this isn't too big a change. It just means that the component Rust Analyzer can now be downloaded as part of your, well, actually, let me just read the thing.
Read the thing.
Okay, Rust Analyzer is now included as part of the collection of tools included with Rust. This makes it easier to download and access Rust Analyzer and makes it available on more platforms. It is available as a rustup component, which can be installed with rustup component add Rust Analyzer. At this time, to run the rustup installed version, you need to invoke it this way. The next release of rustup will provide built-in proxies so that running the executable Rust Analyzer will launch the appropriate version. Most users should continue to use the releases provided by Rust Analyzer team, available via the Rust Analyzer page, published more frequently. And if you use VS Code, you don't have to do anything because the extension downloads it for you automatically whenever there's a new release. So yeah, if you're not on VS Code, then this makes life easier for you.
Yeah, it's pretty cool. I think also invokes it for more platforms. I don't know, like, because I guess I've been using VS Code on Windows. I feel like it's easy for me to update, but
yes,
if you're not on the major OSs, probably easier.
Yeah, but also not major editors. If you, for example, use Vim from the command line or Emacs or any other editor, then this just makes it easier to use it.
Nice. There's been some cargo improvements, workspace inheritance, and multi-target builds. When working with collections of related libraries or binary crates in one cargo workspace, you can now avoid duplication of common field values between crates, such as common version numbers, repository URLs, or Rust versions. Oh, thank fuck. Oh, this is good. I'm excited. I'm reading this. I understand what this is. This also helps keep these values in sync between crates when updating them. For more details, see workspace package, workspace dependencies, and inheriting a dependency from a workspace. When building for multiple targets, you can now pass multiple -- target options to cargo build. To build all of those targets at once, you can also set build target to an array of multiple targets in cargo config.toml to build for multiple targets by default. This is really nice because I, for example, I always forget to keep my dependencies, packages, version numbers up to date in my workspace because I'm forgetful, and it's nice. I don't have to worry about that anymore. I'm very happy. So I seem less forgetful to other people, which is great. Thank you for this addition, whoever worked on this.
I saw a funny tweet by Tef the other day.
Oh yeah.
Yeah. Which I think they tweeted out ages ago, but it was something like blaming the root cause of a failure on human error is like blaming a house collapsing on gravity. Right? So to me it feels like you're like, oh, I'm a forgetful person, I make mistakes. I'm like, yeah, everyone does. If you make mistakes, that's not your bad. It means the tool doesn't provide you with ways to not make those mistakes, and it finally does, and I'm very happy for that.
Yeah, I think that's a nice way to think about designing tools in general. Prevent your users from making mistakes.
Oh my god, yes.
That's how you should be thinking about it. It just makes life for everybody easier, I think.
Do you know?
Just like empathy-driven development. You think about your users and you prevent them from like making stuff up and like screwing up and
Yeah.
just help each other out. You were gonna say.
Oh god, like someone else. Oh my god, I like my brain is like twitter.com, like it's an endless like timeline of like
It is
tweets I
true. I
remember.
can concur.
But there was someone else who was like, I think it was Esteban, who was like, if any rule like takes more, if any like set of rules takes like more than a page or more than 5 minutes to like reason about, then it should be automated.
Right.
It might have been someone else, but it's like, yes, absolutely, because people
Exactly.
make mistakes. And there's a tool coming up, which is not part of any release quite yet, but people are talking about perhaps integrating it into Cargo, which is semver checking. You make a change, and the tool will tell you if it's semver compatible or not. Like, is it semver major? Is it semver minor? Is it semver patch?
Oh, that's really nice.
Yes.
I mean, the cognitive load at this point of like, you know, working in software for 10 years, you kind of like know it, but like if you don't have to think about it, that's nice. You can think about all these other things instead of thinking about
Yes.
whether something is a semver minor or a patch.
Exactly. And one of the things that I'm like super keen about, because like semver at its core, everyone's like, oh yeah, I get semver, but then you ask anyone like explain variance and contravariance to me, and like people are going to be like, what is that? Why should I care? And then you explain it and you're like, what? And I half get it, but tools can check it for you because it affects semver.
But also the specs for those things are like a page long, and you shouldn't expect everybody to read a spec to be able to use a thing. Like tools should be able to do the spec checking for you. Plus there's so many different specs a person could be working with.
Says a person who works with specs.
I literally,
yeah.
I literally work with spec.
Oh, I took semver v1.2.3, not v3.2.4. You know, however version. Yeah.
We have deviated from.
Yeah. Anyway, tools good. Automation good. Excited. Yes.
A bunch of APIs stabilized. Future.IntoFuture. We
That's
just
right.
talked about that, but we're happy it's stabilized.
Oh, damn. Check out all the non-zero types have a bunch of checked, overflowing, unsigned methods.
Oh, nice. Very nice.
Yeah. So
Did non-zero used to be a crate of its own and didn't get merged into stable? And this could be a crate of its own. It was a crate of its own like 5 years ago.
wait, when was not? No, we can see when non-zero was introduced. 128.
I think it was a crate of its own. Was it?
Potentially. Like, this is before my time, basically.
Yeah.
Maybe you're thinking of the const number stuff.
Maybe.
Because const arithmetic, like const generics, they got merged like after
No,
we started doing this.
I know about const generics
Yeah.
being its own crate, but no, I'm thinking something about number related being its own crate.
Yeah.
Anyways, we're deviating again. Well, welcome to our scatterbrain.
No, it's fine.
Actually,
It's fine.
this seems good, like standardizing kind of any number workings with.
Yeah. I think before this, you had to probably, if you wanted these kinds of things, you have to like cast to a U size first. But now you can just like do it directly.
Does non-zero actually do like provide with a cast too?
Yeah. So a non-zero says, hey, zero can't be represented. And you can like convert it, where is it, to an option of U size or something.
Oh, okay.
Yeah, here you go. Even this conversion, check null.
It's a non-zero U size.
Yeah. No, there you go. Okay, whatever. Yes.
Yes.
Okay, good.
So a bunch of non-zero stuff and non-zero I stuff. And then there is some WOSH things.
Yeah, I don't know what this is.
Process group.
So set the process group ID of the child process equivalent to set PGID call in the child process, but may be more efficient. I do not like processes at all. Very excited for the new IOU ring process group stuff. That will make this easier. Hopefully someday. Examples. Pressing Control C in a terminal will send SIG to all processes in the current foreground process group. Okay. By spawning the sleep subprocess in a new process group, it will not receive SIG from the terminal. The parent process could install a signal handler and manage the subprocess on its own. A process group ID of 0 will use the process ID of the PGID. Okay.
This needs an illustration.
Potentially.
I sort of follow it, but I feel like process stuff just in general needs some illustrations.
So my understanding is processes on Unix have groups. You can, all these processes are grouped into a thing. This allows you to say, actually, this process is a different group, which is a thing you can do. And then signals to it will work differently because that's how processes work or process groups work on Unix. Okay. Oh, I startled the cat by laughing. I'm so sorry, naughty cat.
She was a snooze.
Yeah.
Oh.
Sorry, we'll react less hard.
Oh.
She's
she's so sleepy.
Her ears are like sideways.
Yeah, she's got like sideways ears.
Very good.
Sideways
Are we
ears.
gonna yawn? No, we're just gonna make eyes.
For her ears are like this, like flat.
Yeah. All right. Next one.
Yes. File type extension stuff. Is symlink dir and is symlink file. So they're kind of grouped together. Returns true if this file type is a symbolic link that is also a directory. And the symlink file returns true if the file type is a symbolic link that is also a file. Yeah, seems like you need that.
Yep.
Seems good.
Sure. It's only on Windows though.
I'm sure the Unix one has that as well.
Does it?
Check. I would assume the Unix ones would get this.
Okay, so let's take a look at is symlink. Okay, wait. We just have file type and then is symlink file and is symlink. Oh, only Windows. Hold on. That's the only one.
What? No, hold on. Go back.
Yeah, I'm looking here. But that's the implementation. This is the implementation of the Windows trait. No.
No.
Unix doesn't have it.
Somebody should make a.
No. I don't know if it can be represented.
Oh, really?
I mean, there's a reason why it would be like Windows only. Either it's hard to do it in a uniform cross-platform way.
Okay.
No, actually, that's the only reason.
Because like symlink on a Unix system is really straightforward to kind of do process-wise, like from a user point of view. But I don't know what it looks like under the hood.
It may be that in Unix, a symlink is a symlink.
Right.
And the symlink itself doesn't distinguish between being a file symlink or directory symlink. And the way you find out is by traversing the symlink.
Okay.
But traversing the symlink may be an operation that actually does I/O. Because here, you look at this and we don't do I/O. This is infallible, right? It's a property of the symlink.
Right. Because you can definitely even from an ls kind of one of the ls commands, just pass it a flag. You can always tell that something is a symlink. I don't know. I can't remember if you can tell if it's a directory or a file. So
ls may be able to figure it out by traversing it.
Oh, so you just traverses under the hood.
I don't know, but I assume that the reason why this is not available for all files, but only on Windows, is because Windows may just have the property built in.
Weird that a Windows has a property built in and Unix doesn't.
I mean, it's
the world has changed.
What?
Usually, I feel like Windows stuff is always OS things are always a bit more difficult to do than they are for a Unix-based system.
I mean, I work at Microsoft.
I'm sorry, I'm asking a political question.
No. I'm just prefacing this with yes, I do work at Microsoft. I have worked on the Windows crate. Windows provides you with many conveniences.
No, I know, but I'm saying I feel like before you working with Windows, it was a bit more difficult, and only recently has it become a lot easier, and that's all I'm trying to say.
I don't know. I don't know.
I just, it's nice. I'm not critiquing it. I'm just saying it's nice.
Yeah. I made this weird for myself, but I was like, I work at Microsoft.
You did make this weird for yourself.
I know very little about Windows. I don't particularly.
Anyways, we just
So before preluding anything with like I work at Microsoft, I should preface it with like I'm a dumbass. So hey, sorry, that's bad. All right. Yes. Core FFI. Oh, these are things that we were taught that were mentioned up earlier.
Yeah.
Yeah.
They do look like it.
So there's C.
Yeah, go for it.
Yeah, there's CSTR from byte. What is this? I've never seen this. From bytes with null error. Null is single L?
I'm confused why it's single L. Is that like a different null?
It must be. It must. Oh, it's a null byte terminator.
Oh, I always
NUL.
spelled a null byte with two L's. Have I been misspelling it?
Possibly.
Oh.
I would assume they didn't make that mistake here.
No, I mean, there is now 4 different things that say null with one L.
Yeah. Well, it's the same method repeated all the time, but I would assume, there would be a note of like we misspelled this, probably otherwise. Okay. Yeah.
And null error and things like that.
Oh, nice. Okay, so these things, they required some allocation stuff. Oh, and here's the rest of them.
Yeah. These are the primitives being re-implemented in the FFI.
Yes.
But the other stuff was what was instead, but is now in alloc and core, which means they can be used in like the embedded systems as well.
Yeah. So this is the string equivalents, which were in alloc, and here's the things that are purely in core. Because none of these require allocations. These may, or like this one is allocation related. Anyway.
Cool.
Yep. All right.
Nice.
Two more of mine.
Oh, these are yours.
These are mine.
Wow, tell me more.
Yeah. We have like 3 async features. The most features of like any like release. So here we have pullFn, which is it creates a future that wraps a function which returns a pull. So how do I explain this? Most people will not have to use this. Let me preface it there. I think the patch notes called out correctly. Like, hey, in the future, we hope to provide simpler APIs that require less use of low-level details like pull and pin. But in the meantime, if you do have to write pull and pin based code, then this makes life easier. So pullFn, you can write a manually pulled future here, and it essentially gives you access to the context in a way that you can like use this thing, and it will like, I believe it will like be called until it like returns. Oh, we should explain this better. That's my bad. It explains it will be called until it like returns a pull ready.
What's this used for?
If you need to manually pull a function, but you're in a future context, right? Here, presumably, yeah, look at this. We're in an async context right here, right?
Okay.
Because we can wait, but for whatever reason, we need to drop down and manually pull a thing,
Okay.
right? Manually drop into pullFn functions. This allows like a very simple conversion between the two. The implementation of the code, it's like this whole thing with docs included is like 60 lines. It's a very simple implementation, just really a little helper thing. Similar to that is task ready. Like,
And this one's this one's a macro.
it is a macro, but what's nice, it is a macro that's in a submodule. Wow.
Okay, how so? Like, what is this used for?
Okay. So, okay. What this is used for is when you're like manually authoring futures. So you implement the future trait on a type. Yeah. You need to do things with pull state machines, and you need to be aware of pinning. These are all like low-level details, but I don't expect anyone to really fully grasp them. But you do have to interact with them. You can't use a wait when manually implementing these things because you implement the state machine that can be awaited. So instead, you will do something like you call, like this is a function that wraps another function that does a poll. So here you say future poll. And if this returns poll pending, just like question mark, you can kind of think of this as like a question mark after this.
Right.
It will say, okay, poll pending, propagate it up. And if it's not pending, then we take the type out of it and we say poll ready. And, we continue here.
Right. So ready is actually a state machine under the hood that has how many states? Pending and ready?
I mean, you can look at the macro expansion, which is like, in the case of ready, we return T. In the case of pending, we say return out of the function.
Okay.
Otherwise, just like out of the scope, it's now this value.
Right.
This works very similar to question mark.
Okay.
Like option question mark returns none, or else it like unwraps it into a value, right? Very much the same. For reasons, we can't use question mark here. Like we stabilized question mark for other things, like the try trait, that is, for different purposes, and they would not be compatible. In the end, we were like, well, it's been almost like 3 years. Has it been? No, 2019. It's been 3 years since we stabilized async await.
Right.
We should provide this very simple convenience to make it easier to write poll-based state machines, because everywhere where do we even like have it here? We may have it here. If we don't, yeah, it's because it's too simple. But pretty much like every future uses ready under the hood somehow.
Okay.
So yeah, it now exists. I hope if you're writing async code, you don't have to use it. You're not writing manual state machines. But if you do, then this is handy.
Neat.
Yes.
And I guess a small change. There's now a small API addition, slice from raw parts for const.
That's right.
Forms a slice from a pointer and a length. Okay. The length argument is the number of elements, not the number of bytes. That's a nice little comment, because I would have thought it was bytes.
So this was always available, but it seems like it's now finally available in const, which means you can construct slices in const using unsafe.
Nice.
Why? I hope you don't need this.
Otherwise it would not be in. I guess some people might need it. Otherwise, it would not be in core.
Yeah, I think Mara, in her like tweet thread, again Twitter brained.
Yeah, definitely Twitter brain.
She described it as like allows you to commit more code crimes. And some people responded with like stuff I didn't properly read, but they were like, "Oh, that's amazing! I get to commit like this atrocity," and it's like, "Oh God!" But yeah.
So a code crime API has been added to context.
Yes.
Contexts.
Yes. Be afraid, I guess.
Or be excited if you commit code crimes.
Yes.
Compatibility notes too. As previously announced, Linux targets now require at least Linux kernel 3.2, except for targets which already required a newer kernel. And Linux GNU targets now require glibc 2.17, except targets which already required a newer glibc. Cool.
Yep. I believe this may mean that very old versions of like people running very old kernels that have a very old glibc may not be able to upgrade to the latest Rust version. I saw someone recommend for cases like that to consider like either stay on the older Rust version, that's allowed, that's valid, or consider switching to muscle libc, which is a portable libc that you can just use on any platform supposedly. What the right call there is, I don't know. This is a minority use case. The reason why Rust felt comfortable upgrading is because glibc 2.17, as I understand it, is very old. And Linux 3.2 is very old as well, to a point that's like not even LTS supported by the main distros. So, but yeah, there's still options if you're stuck. Yes. Shall I read it?
Sure.
All right.
I read the previous one. Your turn.
Fine. Rust 164 changes the memory layout of IPv4 adder, IPv6 adder, and socket adder v4 and socket adder v6 to be more compact and memory efficient. This internal representation was never exposed, but some crates relied on it anyway by using stdmem transmute, resulting in invalid memory accesses.
Are they shaming? That's by using it anyway.
I mean, kind of. Some people they don't like have a different option really, but yeah. Anyway, you shouldn't rely on the layout of things unless it's specified like, "Hi, we have a stable layout," and that's a minority of things. Anyway, the next sentence says, such internal implementation details of the standard library are never considered stable. To limit the damage, we worked with the authors of all the still maintained crates, made sure that new fixed versions were released, and they've been released over a year ago. So most of people who will be affected by this change should be able to mitigate it by cargo updating, which is to say, like, hi, we could have broken stuff. We chose not to break stuff. We may break stuff in the future. This is not a guarantee that if people are indeed doing invalid transmutes, relying on internal details, that you can be, and no, wasn't that stable? The answer is no. No, it wasn't. But they're highlighting of what should and should not be considered stable. And even if mitigations have been put in place, there's no guarantee that they will in the future. So don't do that. Don't assume that Rust teams will bail you out in this case. It's okay. Yeah. There's the thing about like flexibility and like internal stability. I know like C++ struggles a lot with ABI breakage, which says the layout of things must be fixed and you can't upgrade it. Rust explicitly does not want to be in that position where the ABI of things is fixed and people are relying on it. So I think calling it out like this gives a good message of like, hi, no, we're not ABI stable. Please do not assume it is. If anything is, like, it will be highlighted extra clear, like this is ABI stable. But if it isn't, it isn't. And, you know, it clearly wasn't, but still, even in that case, good things done. Yeah.
Cool.
All right.
As part of the RLS deprecation, this is also the last release containing a copy of RLS. Starting from Rust 1.65, RLS will be replaced by a small LSP server showing the deprecation warning. Cool.
Yep. We've got Rust Analyzer now.
We do. Rust Analyzer is great.
It is. All right. Other changes in Rust 164. Yeah, every time I say something, she's like, oh my God. Still a cat right there, right there.
She's
she's jumping down.
She's leaving.
You want to come on camera? You want to pick her up? Oh, no, she's gone. Oh, such a sweetheart. All right. Windows builds of the Rust compiler now use PGO, Profile Guided Optimization, providing performance improvements of 10 to 20%. Yay.
My computer is really fast. It's very good. Imagine 10%, 10 to 20% performance improvements in compiling on Windows.
Nobody knows how fast your computer is.
I am telling you, it's very fast.
I'm sure everyone will appreciate that.
Yeah. Very excited.
I believe in terms of like performance improvements, I asked around on Twitter, and I believe it was LQD who did the majority of the work. Wesley from the compiler team and LQD together did some stuff around this, but LQD was leading. Anyway, I asked, and it seems like most of the improvements will be closer to the 10%, 10 to 15 maybe. It's exceptional to hit like 20% improvement, but 20% improvement if you like want to have a bit of a sense for it. I believe that's sort of the typical difference between one generation of processors to the next generation of processors. So it's like, if you bought a fancy processor for compilation, then this will just bump you up like a little bit. Not like a full generation, maybe in some cases, but kind of like just a bit better, which is very exciting. Do you know what profile guide optimization is?
No, I don't actually know about that one. Would you like to talk about it?
I'll explain. I was giving you a chance for you to explain.
I actually don't know. No.
All right. So PGO, if you're familiar with languages like Java or JavaScript, then what they'll do is they have a runtime optimizer. If some loop is run 1,000 times or 10,000 times, then they're like, hey, you're a hot loop. I should make you as fast as possible. And then the interpreter spends a bunch of time crunching numbers to make that usage as fast as it can possibly be. In compiled languages, you compile it ahead of time, and then there's your binary. Now, PGO, what it does is it compiles a binary with instrumentation points. Then you run it. You run that binary. You benchmark that binary. And then the instrumentation points will say, actually, this is the hot part of the code. And if we change the ordering of certain things, or make certain things like faster, or make the loading of particular things quicker, or reorder things, then we can improve performance based on how we actually know this thing will be used.
Okay.
Right? So it uses the runtime to improve, like runtime knowledge, to improve output of the compilation.
So does the binary then does the binary get written to actually so it benchmarks at runtime, but you need to store that benchmarking information. So where do you store it? Do you store it back into the binary?
No. You feed the benchmarking information back in the compiler.
Okay.
And then you compile the binary again with that information.
Okay.
Now, I don't know how the Rust compiler does this loop, whether for every release it compiles it, takes the information, and then compiles it again.
Right.
Or whether that information is periodically generated and you just have a PGO profile that you use again. I assume because it changes, you want to benchmark it again so you can generate a profile for that new binary.
So I guess it will just live in the target dir of your crate.
It may just be as part of the release process.
Okay.
It creates a file somewhere indeed, and then feeds it back in. But yeah, it already used to happen for the other targets. I believe definitely Linux. I believe macOS probably as well, but now also for Windows. So we get the same benefits, and that's exciting.
Nice.
Yeah.
If you define a struct containing fields that are never used, Rust-C will warn about the unused fields. Now in Rust 164, you can enable the unused tuple struct fields lint to get the same warnings about unused fields in a tuple struct. In future versions, we plan to make this lint warn by default. Fields of unit type unit do not produce this unit type unit. Do not produce this warning to make it easier to migrate existing code without having to change tuple indices. So this is a diagnostic exchange.
Yes.
Nice.
I never knew that if you had a struct with tuple fields that you didn't use them, you wouldn't get a warning. This makes perfect sense to me.
Yeah, it does. I guess I've never used a struct with tuple fields.
Interesting.
I've never had to.
I mean, you never have to. It's just sometimes quicker to write.
Yeah, I think I'm too pedantic, maybe.
You can always name your fields. That's how
name fields.
Yeah.
How will I remember a month from now what this first field in a tuple I refer to?
Yeah, I find it useful when you're creating just a wrapper, a new type.
Right.
So you just have the inner thing at position 0. That's just a wrapper. But yeah, indeed, naming fields is useful. But this, yeah. It used to be a case that we didn't have like named fields. We only had tuple structs.
That was before my time.
Yeah, I don't know if that was Rust 1.0, but that definitely at some point in time that was the only thing that existed.
Wow.
Yeah,
How far we've come.
we can name our structs now.
Wow.
Our fields and structs have
Wow.
names.
Such luxury.
I know. You don't know how good we have it now.
Yeah.
God. Extern crate.
Oh my god, didn't I? External crate was so confusing.
I know.
So confusing.
I know.
How far we've come.
Yes, we have. All right. I think that's about it. Like, yeah, I don't want to go through like all the changes.
That sounds good.
Yep. If y'all like want to read the release notes in more detail, sure. You can click through, go to the full patch notes for Rust, for Cargo, for Clippy. They're here in the thing. The changelog itself you can find on the Rust blog. Just search for Rust blog 164 and you'll find it. With that, I think we're at the end.
Yeah. Thanks so much for joining us.
Thank you.
Hope you enjoyed.
And we'll see you in 6 weeks.
6 weeks. Long time. Hope you don't miss us too much.
Not if we act like that.
That's true.
All right.
Shut it off.